Hello guys, today we're going to be studying for the AWS Certified Solutions Architect certificate. Now we're on the third category. We're going to go over databases. So let's go ahead and figure it out. Let's see. What is a database, right? Okay, so a database is a place where we could store our structured data. We could retrieve it quickly and update it safely. And it can handle many users at once. So let's go ahead and scroll down. So why do databases exist? Well, we need to store user data, orders, product information, and payments. Right, so how do we do that? We have to find users instantly, so we do a user lookup. So it's good for user lookup. Number two is good for update order. And connect users with their orders. And go adjust my pen size. Okay, cool. So we need to find a user, instantly update an order, connect users to their orders, and ensure that no data is lost. So S3 cannot do this well, so that's why we have databases. So S3 kind of just gets data, it just stores data. And databases organize that data. Right? So it kind of helps you out. So let's go ahead and try to figure out the difference between these two so you guys could get a good idea. So S3 just stores files and it has slow queries. There's no relationship between the datas and there's no transactions. But databases store that data structuredly, it has fast lookups, and supports RDS and supports transactions. So now we have to figure out the three core types of databases which we should know. Well, the first one is RDS, which is relational data system, relational SQL. So, and another one would be Aurora, which is advanced RDS. Basically just RDS, except I guess more advanced. And DynaDB is serverless. Let's go through each one of them now more in depth. So we could think of SQL database in AWS. That's what an RDS is. So database, except in AWS. So what is a relational database? It's basically uses columns and rows in a table format. So let's go ahead and draw that out. So over here, an example of a relational database could be like we could have something called student, right? That's the table name. Let me actually write this better. Right, so a column could be like ID, and this is like the instance of that. So this could be like name or school name. So ID could be like 2. The student is just the table name. Name would be like, I don't know, like Eric. So this is a column, and this is a row, an instance of an ID, an instance of a name. And we could run SQL commands on this, which is stands for SQL, stands for Structured Query Language. Okay. Why relational? Because every single part of the data is connected. For example, if I have a something called like students and teachers, teachers teach students, so that's why we call it relational, right? Here, let me draw this out. So let's say we have a table called students, and it has information like name, has things like birthday, right? And this is another one called teachers. And they could have other stuff inside of it. It could have a student inside of a teacher, right? So we could say students could be a column. Another column could be like subject. Another column could be like amount of classes it teaches. And one could be like school. You see how students are in teachers? So that's why we call it relational, because the data is connected. And let's see, I guess from this example, we see that Excel has spreadsheets. So there's multiple sheets which are connected by IDs, and that's a relational data. Let's figure it out. What is relational database system? Let's go ahead and look at RDS, relational database service. Okay. So RDS is managed by SQL database hosting. So ADF handles the backups, patching, replication, failover. So we still have to choose the instance size, manage queries, and design schemas. So when should we use RDS? We should use RDS when we have structured data and relationships matter and we need joins and ACID principles are crucial, which stands for relational database system. E-commerce. So e-commerce uses these. So we could have e-commerce. For example, it would have this. We'd have stuff like users. We'd have like orders, product, and then these other things could be like user. Could have their own tables saying like ID, transactions, and order could have like transaction ID. Part, yeah, you get it. And then these all go inside here, and that's why they're relationships. So this Amazon's version, AWS of I guess relational tables, database tables are called RDS. So key features of RDS. So RDS is it's high availability, so it uses multiple area zones. So it creates a standby in another area zone. If the primary falls, then it go ahead and just use the other ones. So let's say this is availability zone AZ1, and this is AZ2. If AZ1 was to fail, we'd go ahead and use AZ2, and that's why RDS is pretty good. So it has good for lookups, lookup. It's fault tolerant. Another one would be updates. Pretty good. Okay, now let's go ahead and let me scroll up again. Do a little quick review, make sure I got everything. Alright, so the main ones are differences from S3, so kind of just stores, slow queries, no relationships. RDS is relational SQL, but for Amazon. Okay. Read replicas. Okay, let's go ahead. So we have also something called read replicas, which are copies of our database. So read heavy workloads, reporting queries. Exam trigger too many reads, read replicas. Um, okay, I think I want to get some more information. So read replicas are good for just, I guess, copying your database. Scaling reads. So I guess instead of having one database, right, we have multiple copies of the database, right? So when we all access the same database, we won't run into issues about querying speeds. We could just access, I guess, one for this, one for this. Okay, I guess kind of have like a load balancer. And that's what read replicas are. So we could replicate the reads. Backups and snapshots. So automated backups, manual snapshots. So I guess this is just in case your database fails, we have a backup of it. So RDS limitations. So scaling is limited, vertical scaling mostly. Not great for unpredictable massive traffic and requires capacity planning. Okay. And we could see Aurora is actually a premium version of RDS. So, so Aurora, I'm gonna say Aurora is equal to premium RDS, which stands for Relational Database System. So RDS is good, but scaling is limited and failover can be slower. So I guess RDS is not as fault tolerant. RDS has limited scaling, not fault tolerant, not as quick to recover. So AWS built Aurora to improve the performance, improve scalability, and improve availability. Wow, it's 5 times more faster in SQL. Wow. Wow, okay, so it's 5 times faster in MySQL. So I'm guessing that's 5 times faster than RDS. Because RDS is like MySQL. And storage auto scales. So as you add more information to your data, I guess the table increases. And up to 5 read replicas. So you're going to have basically like 15 read replicas. So I'm guessing you could have a lot of reads on different servers to speed up the query lookup time and distribute storage across AZs. When to use Aurora. It's when you need high performance, high availability, many read replicas, and scalability. So let's see. When you need global scale, many read replicas, and HA. What's HA? High availability and minimal management. So when do we use RDS? When to use RDS? When structured data relationships matter, need joins. Okay. Okay, now let's go ahead and look at the difference between these two. So, Aurora versus RDS. So performance, it's very high, very much high. Scaling is only limited for RDS. Replicas, not much. Copy. This is basically a copy of your tables of your database. Cost is cheaper and cost for Aurora is much higher. So DynamoDB, NoSQL serverless, infinite scale key value database. No strict schema. Okay. So now we learn about NoSQL. So no joins, just no strict schema. So instead we use key value pairs and flexible structure, and it's ultra fast. Okay, let's see. An example could be JSON user ID is 123 cart. You access data by key, so get item where user ID is 123. Okay. Unpredictable traffic, low latency, serverless. So no servers to manage, auto scaling. Single digit millisecond latency. So it's mega fast, handles huge traffic. When to use DynamoDB. When there's simple access patterns, massive scale, unpredictable traffic, and low latency is required. Real example would be user sessions, shopping carts, IoT data, and click streams. So the limitation is that there are no joins and harder data modeling, not for complex queries. So if we see something called unpredictable workload, we want low latency, a massive scale, and serverless. Okay. Okay, so NoSQL. NoSQL means, okay, so this one means we use a database, and this one means we don't use tables. No tables. No relational database. Queries will be complex. These are much simpler. We could just write a command as we seen earlier, say like give me ID, give me items from user ID 123, something like that. That was from above. Scaling is massive, so we could scale very easily. Relationships, yes. Management, minimal. We don't even have to manage it. Okay, let's go ahead and figure it out. Do we need relationships and join? If no, then we go ahead. Oh, okay. If we need relationships and joins, then we could use RDS or we could use Aurora. If no, I think we should go ahead and use Dynamo. Is the scale massive and unpredictable? Yes, use Dynamo. No, then use RDS. Or we could use Aurora. I mean, I don't know why it's not saying that. Need high performance and scaling SQL? Aurora, yep. Let's go figure out the key critical exam patterns now. So we have read heavy workload. So if it's read heavy, add read replicas, use Aurora. High availability, use multiple AZs. Unpredictable traffic, use DynamoDB. Low latency at a scale, DynamoDB. So I think, wait, so does that mean we could have an RDS plus read replicas? I thought it would have read replicas already, right? Okay. Complex queries use RDS. Minimal operational plus relational. Using S3 as a database. S3 is not a database, it's storage. Trap 2 is using RDS for massive scale. No, DynamoDB is better. For getting read replicas, classic scaling solution. Ignoring multiple AZs, always needed for, what was HA again? High accessibility. Choosing DynamoDB for complex queries wrong, use RDS. So orders, users and orders, we use that. High availability, we use multiple AZs, many read replicas. High scale app, millions of users, we have to use DynamoDB. A global app with heavy reads, we use Aurora with replicas. Teach back. RDS is a traditional SQL database where data has relationships and needs complex queries. Aurora is a much faster, more scalable version of RDS with better performance and availability. DynamoDB is a serverless NoSQL database designed for massive scale and low latency with simple access patterns. So let's go ahead and answer these quick. Okay, we need joins and structured data. I think we should use RDS, right? Because needing joins means that we cannot use DynamoDB. You could also use the other one. We could use Aurora, but it's not needed because they didn't specify that it was hard or a lot of queries. We need massive scale and unpredictable traffic. Well, that's what DynamoDB is for, right? Because we want to scale massively. We need high availability. We should use what's the AZ availability. We need scale. We need to scale and read traffic. I guess to read traffic we'd use Aurora. Right, if we didn't need to read traffic, let's see. Read traffic. Let's see. Read traffic. Yeah. Wait. So, is it a standalone thing, or does it always be used with RDS and Aurora? Is it? It's not a standalone. Features of database. They're like explaining it kind of like it's a standalone service, right? Because right here they said, all right, multiple read replicas. Okay. Read replica purpose performance scale reads. Okay, multi-AZ availability standby copy not used for reads. It's only used if the primary fails. Read replica exam 1's to read replica. So look for read heavy. Performance issues, too many queries, slow select, add read replicas. Very high end, need many replicas, better performance, minimal management. Asynchronous. It's is read. Okay, let's go ahead and answer these. Let's see. Is read replica a separate AWS? No, it's not. No, it's add to RDS. Okay, what is the purpose of read replicas? To speed up queries. What is the purpose of Mosey? For fault tolerance. If you need many read replicas and better performance, what should I use? Aurora. If you could answer these cleanly, you locked in. Okay, yeah, I did. Let's go. All right, guys, that's how I answered. That's it for databases. Let's go. See you later.